Welcome back, Algebra 2. Today we're going to continue with our rational expressions. Remember, rational is just a fancy word for fraction. We simplified last time we were together, and today we will move into some operations. So we'll be doing some multiplying and dividing specifically. So on the screen, as you can see, if you want to take this note down really quickly, just the rules for multiplying and dividing rational expressions. They're the same as multiplying and dividing fractions. So for multiplying, we're just going to multiply straight across. And then for dividing, we're going to multiply by the reciprocal of the second expression. So you can see there that C and D are flipped here. And then we're going to multiply. So just like when you would multiply by fractions. All right, let's look at some examples. And again, our key ingredient here is factor, 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 right? So that's always something that we want to think about first. Can I factor this? Can I cancel this? Can I simplify this? Any of those tips will help here. So let's look at example 1. And I'm going to show a couple of different ways. We're going to show the long way. And then we're going to show the way that I like to do it, because you know me, I like to save energy wherever we can, all right? So here's our first one, 4x cubed y divided by 3x y to the fourth times negative 6x squared y squared divided by 10x to the fourth. All right, so our rule in multiplying is just straight across, right? So I can use using my exponent rules, go ahead and multiply my numbers here, or my coefficients, and then add my exponents. So I have x to the fifth, y to the third, divided by 30x to the fifth and y to the fourth. Next step after that is simplify. So can I reduce my fraction here, 24 over 30? I can reduce it by 6. So I have a negative 4 and a 5 in the denominator. I can subtract using my quotient rule. So I have no more x's, those cancel out. And if I subtract here, I get a negative 1, so we have a y in the denominator. So that is your simplified form, negative 4 divided by 5y. Another way that you can do it, sometimes when you're multiplying, things can get pretty yucky and pretty large if I have large numbers or if I have binomials and that kind of thing. So what I can do is I can cross cancel, right? So I can look at diagonal numbers here or terms, and I can see, okay, how can I reduce this? Well, I can reduce my numbers by 2, so that becomes 2 and that becomes 5. I can reduce my x's, right? So I can reduce all of those and that becomes 1x, and I don't have any y, so I can't do that. Then I can look this way. All right, well, 3 and 6, that becomes 2, right? And then x squared and x cancel there, cancel that squared. Y squared and y to the fourth, this becomes y squared, right? If this gets too messy for you, you can go ahead and do the first method. That's totally fine. You should get the same answer. So I have 4y divided by 5y squared. Continue simplifying, negative 4 divided by 5y. So anything on the top can reduce with anything on the bottom, okay? I mean, we could have gone here and reduced those first and then came up with our answer. Either way. I like this. When we get a little bit more messy, you may like this too. Or you can do what we did at the beginning and multiply straight across. Either way works. Up to you. Let's look at example 2. This may work here in our favor when we have some binomials. So I have 4x squared minus 4x divided by x squared plus 2x minus 3 times x squared plus x minus 6 divided by 4x. So remember when we talked about our number one rule was factor, 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 right? So we're going to see if we can factor any of these terms here. So I'm going to look up here, 4x squared and minus 4x, and I know I can pull out a 4 and an x, right? So I have x minus 1 there in the numerator. In the denominator, let's see what I can do here. What multiplies to get -3 and adds to get +2. I'm going to say it's +3 and -1. How does that sound? And then times, let's factor up our numerator here. So I have x, what multiplies to get -6 and adds to get +1. I think that's a +3 and -2 there. And the denominator just stays. We can't factor anything out of there. Now I can look to cross cancel, right? You can multiply straight across and just mush them all together, or you can go ahead and cross cancel. I know these can cancel here. Anything on the top can cancel with anything on the bottom. This is coming out quite beautifully. So what do I have left? I have just an x minus 2. That was nice. All right, so let's say that I didn't cross cancel and we just multiplied straight across. It would be 4x, x minus 1, x plus 3, x minus 2, right, divided by 4x, x plus 3, x minus 1. So really we just end up writing it again, and then we can cancel and simplify there. Ends up with the same answer. All right, let's do another one. Let's do example number 3. We're actually dividing on this one. So before we do anything, I want to make sure that we are following our division rules. So when we divide fractions, we're actually going to multiply by the reciprocal of the second fraction. So let's look at this. 6x plus 2y. All right. So I'm going to factor the first one. It's a difference of 2 squares, so I know it's x minus y, x plus y in the numerator. I can pull out a 2 here, so that's x plus y here. And then I'm going to make sure to multiply, right? So I'm going to look at the denominator. Can I simplify? You can do this in 2 steps. You don't have to do this in one step like I am. You can multiply first and then factor. 3x plus y, and then in the numerator, what do we have? Looks like we're going to have a 2x and an x and a y and a y. I'm going to make sure that I can, is that correct? Negative, negative, yeah. All right, so I get a -2, -1. Nope, that wouldn't work, would it? Is that factorable? Let's see. Well, now I realize it's because I wrote this down wrong, wasn't it? That's supposed to be a 3. Okay, I got a little bit confused. All right, so 2x and x. We have a y and a y. And I know that's going to be negative and a negative. So I have a -2y, -1. That gets me my -3x. All right, we're back on track. Okay, so let's see. What can we cross cancel? And then that looks like it should cancel with something, but it doesn't, does it? So x plus y, x plus y, x minus y, x minus y. Ooh, the 2's can cancel. That's nice. So what do we have left? We have a 3x plus y in the numerator and a 2x minus y in the denominator. Not too shabby there, not too shabby. All right, I'm flipping to the back. We have complex fractions, which complex fractions, thinking about fractions themselves, what do they actually mean? They actually just mean division, right? So anytime I see this line right here, you can think of a fraction, but it's sometimes we say over, but over isn't actually mathematically correct. It's really divided by. So this is x squared plus 2x minus 3 divided by -3. And then you have another 4x plus 12. So this is x squared plus 2x minus 3 divided by -3 divided by 4x plus 12. So it's just written vertically instead of horizontally. So if I were to write this as something that's recognizable, I could just write that 4x minus 12 or plus 12 like this, 4x plus 12. I'm going to make it a fraction by placing it over 1, right? So that's a little bit easier to work with. All right, so let's see if we can factor, and we'll multiply by the reciprocal. So let's see, x and x, what multiplies to get -3 adds to get 2. +3, -1. I think that works. times reciprocal, remember? So I'm going to take out a 4 here, and so this is an x plus 3. Okay, not too bad. We can cancel these here. So in the numerator, multiply straight across, we have an x minus 1. Denominator, we have 4x minus 3. Go ahead and leave it like that. You don't have to multiply that 4 out. And that should be your simplified form. Okay, so the next thing, we're taking a further look, right? So we're looking back at example 1, 2, 3, and 4, and we're looking at our domains, right? So I want to know, and remember when we find domain, it's from the original expression, not the simplified form, right? So I want to know what is our domain for these expressions. So let's look at example 2. Example 1 has a y in there, so it's kind of difficult to see. But let's look at example 2. My function here would be 4x squared minus 4x divided by x squared plus 2x minus 3 times x squared plus x minus 6 divided by 4x. So I'm going to think about it like this. If I factor this, I'm going to say, okay, this is x plus 3, x minus 1, and then I have a 4x here. Using my zero product property, remember they can't equal 0. Using my zero product property, I'm going to say, okay, x plus 3 equals 0, x minus 1 equals 0, and 4x equals 0. So x equals negative 3, x equals 1, and this is just 0, x equals 0. So let's see what this shows us here. The ones that I could cancel, now I forgot which ones I could cancel, x plus 3, x minus 2. This was a 4x and x minus 1. Okay, so I was able to cancel this one and this, I was able to cancel them all, wasn't I? So what we're going to see is we're going to see points of discontinuity here. So let's see what this, and I looked up Desmos for those of you in 4th period that were confused about it. I looked up in Desmos to see why, and Desmos doesn't have points of discontinuity yet, or those holes that we were talking about, but if we hover over those points, we can see the point of discontinuity. So let's pull this up in our Desmos. Okay, so let's look at this function on the graph. It took a minute to plug it in. So this is our original function, right? And I think our simplified form was a linear function, right? Because we canceled out everything. So we just had that, what, x minus 2, right? No, it was a positive x plus 2 on the top. So if we look at this on the function, we said that x cannot equal, let me pull my screen over here again. X could not equal negative 3, right? So that's our domain. X could not equal 1 and x could not equal 0. So I want to know, because usually they're asymptotes, right? But because we could cancel all of these binomials or all of these little terms here, they're going to be points of discontinuity. So we'll have a point of discontinuity at x equals negative 3, x equals 0, and x equals 1. These are going to be undefined at this point. So let's look at them and see what they would look like on the graph. So let's look at negative 3. All right, so negative 3 is here, right? Oh, look at that. Negative 3 is undefined. So the next one was positive 1. So at positive 1, my graph is also undefined. So see how it kind of, I can scroll over it. It's solid, solid, solid. There at 1, it's a hole, right? Even though Desmos doesn't automatically put them on there, you can see them when you hover over it. All right, and 0, actually I'm clicking on it. 0 is also undefined. So we have 3 points of discontinuity here. At 1, where is it? There it is. At 1, 0, and that negative 3 value. So keep that in mind, that even though we have a linear function here, because it started out as a rational equation, operation, or function, that we have some holes to deal with. All right. So I'm going to let you do example 4. So here we have y's here, so it wouldn't make sense for us to do, for example 1. Don't do that one, and don't do 3. But I want you to do number 4 and find either those asymptotes, right? If they don't cancel, it's an asymptote. If they do cancel, then it's a point of discontinuity. All right, so try 1 and 2. That's your, actually let's do 4 together, right? We simplified it already, so we'll do that really quickly again. You can speed through this part if you want to. Plus 3, x minus 1, x minus 3. This was 1 over 4, x plus 3. All right, so we simplified to x minus 1 and x minus 3. What does that look like on the graph? So we should have x minus 3 equals 0, 4 equals 0, and then x, oh, you can't see that. And then x plus 3 equals 0. So x equals positive 3, that doesn't work. And then x equals negative 3. So because this one canceled out, this should be a point of discontinuity. So let's see what this looks like on the graph. Move you all the way over. Remember, we're putting the whole thing in. I'll pause this, save us some time. Okay, unpause. Let's look at this on the graph. How to get it in there first. So we're looking at where x equals 3. Look at that, x equals 3. So here's our asymptote, right? It's that boundary line. But at x equals negative 3, right here, it's undefined. So think, if they cancel, you're going to have a point of discontinuity or a hole. If they don't cancel, like our x equals or x minus 3 value, then it's going to be that asymptote here, okay? We'll talk more about that next in the next 6 weeks when we get into solving equations and functions, but these are good to know right now. So you have, this is what this would look like in your notes, okay, in example 4. X equals 3 is an asymptote. The other ones were all points of discontinuity. And where x equals negative 3, this is a point of discontinuity. Okay. All right, so try 1 and 2 on your own. We'll come back together at the beginning and share this with each other, okay? All right, see you soon.